Okay, hi everybody. Here we go again. This is review number 8. Yes, it's review number 8, and it's actually a review of, just setting up my equipment here. It's actually a review of your units number 7, which was finite math, sequences and series, in other words, and the financial math. So we're doing all of this in one go, in one review. So we have our work cut out for you, for us, for you as well as for me. Okay, just the basic formulas you need to know. Remember, Unit 7 and Unit 8, if you knew the formulas and practice, it's very straightforward units, the discrete functions as well as the financial math. So again, Pascal's formula using combinations. Well, any term in Pascal's triangle is equal to the sum of the terms immediately above it, right? And you know that the sum of the terms in any row in Pascal's triangle is 2 to the n. The expansion, which Pascal's triangle helps us do, saves us a lot of work when it comes to multiplying binomials. The a plus b to the n is n choose 0, a to the n plus n choose 1, a to the n minus 1b plus n choose 2. I didn't need that bracket there. No sense putting it in if we don't need it. Is a to the n minus 2, b to the 2 plus n choose 3. A to the n minus 3, b to the 3, dot, dot, dot. We'll continue down here, plus the second last term in this expansion, n choose n minus 1, a, b to the n minus 1, plus n choose n, b to the n. Okay, so let's do a few examples involving Pascal's triangle. Now you know any term is equal to the sum of the terms above it. So that would be 12 choose 5 plus 12 choose 4. And all I'm doing is, that's at 12, all I'm doing is the row before, the row above in Pascal's triangle obviously would be the 12th row, n equals 12, and then we choose 5 and 4. Now this one here, working the other way, two terms in Pascal's triangle equal the term immediately below this. So this would be 2, 9, 5. Okay, 2, 9, choose 5. Okay. What would be the sum of the numbers of Pascal's triangle in a row where n equals 7? Well, it's just 2 to the n, or 2 to the 7, and that works out to be 1, 2, 8. Oh, thank goodness. If we were to write all the terms in this expansion, you know there would be 10 terms, or n plus 1 terms. 9 plus 1 equals 10. Fortunately, they're only asking us to do the first 4. So let's set ourselves up. That's 9 choose 0, 2x to the 9, plus 9 choose 1, 2x to the 9 minus 1, which is 8, and that's going to be negative 1 over x to the 1, plus 9 choose 2, 2x to the 7 times negative 1 over x squared, plus, I hope I can fit this in, 9 choose 3, 2x to the 6, negative 1 over x to the 3. Barely got it in, but it's snuck in there. 9 choose 0 is 1. 2 to the exponent 9 is 512, right? Remember that exponent applies to the 2 as well as to the x. Just let me check my calculations because I don't want to leave you with any wrong answers. So that is 512. Now this is going to be 9. 9 choose 1 is 9. 9 choose 1 is 9. And 2 to the exponent 8 is 256. So 256 times 9 equals 2. Here, let me do that again. I just had to talk to someone. 9 times 2 to the exponent 8 is equal to 2304. And, oh, notice there's a negative number here with an odd exponent. Because we have a negative number times a positive number, this will be a negative number. So we have x to the 8 divided by x will make that x to the 7. Because we're multiplying by 1 over x, so that will make that x to the 7. Now 9 choose 2 is equal to 36. Times 2 to the exponent 7 is 4608. And that's x to the 7 divided by x, so that's going to be x to the 6. Now there's alternating plus minuses. This has an odd exponent, so we know we're going to have a negative there. 9 NCR3 times 2 to the exponent 6 is equal to 5376, and that's x to the 6 divided by x to the 3. And that's going to be x to the 3, right? And I just noticed I made a mistake here. X to the 7 divided by x to the 2 will actually be x to the 5. So I'm just going to just take a quick look to make sure. 5, 1, 12, x to the 9, 2, 3, x to the 7, x to the 5, 5, 3, 7, 6, x to the 3. Good. And so on and so forth, because there are 1, 2, 3, 4. There's 6 more terms in this expansion, but they only ask for the first 4. Okay. Reviewing arithmetic sequences. If you recall, the formula is Tn equals a plus n minus 1 times d. Remember, a is the first term, n is the number of the term, and d is your common difference. Okay? So now they're giving us 2 terms, and you need, in any question involving sequences and series, etc., you have to show you know the formulas, because we're really testing you on knowing the formulas. So let's look at this one here. We are using the formula Tn equals a plus n minus 1 times d. So our Tn is negative 9 equal, we don't know a, we're given 2 terms, and now we want to find the general term, or the formula for the term, or the Tn term, okay? So plugging it into this formula, we don't know a, we don't know d, but we know the term number is 4. 4 minus 1 is plus 3d. We call that equation 1. Then equation 2, we'll use this information, and we'll have a system of equations which we can solve by elimination or by substitution. I prefer to do it by substitution. So negative 21 equals a plus 7 minus 1 is 6d. So we have, now I'm going to solve using substitution. 1 minus 2. Negative 9 minus 21 is 12. A minus a is 0. 3d minus 6d is minus 3d. Divide both sides by negative 3, we get a d equals negative 4. 12 divided by 3. 12 divided by negative 3 is negative 4. So now we can sub d equals negative 4 into 1. So negative 9 equals a plus 3 times negative 4, coming up here. Negative 9 equals a minus 12. Negative 9 plus 12, that means a equals 3. So now we can find our Tn, or our general term, or our formula for the term. We have Tn equals a plus n minus 1 times d. So Tn equals 3 plus n minus 1 times negative 4. And you should simplify 3 minus 4n plus 4. 3 minus 4n plus 4. So, and that equals 7 minus 4n. Tn equals 7 minus 4n. That's our answer. That is our general term given this information. Okay. Recursive formulas. Well, let's take a look. 3 parts of a recursive formula are 1, the starting terms or feeder terms. Okay, starting terms or feeder terms. There should be the actual recursive formula, actual recursive formula, and then you should also have the restriction on the variable.
Miss Van please contact room 135, please. Miss Van please contact room 135. Thank you.
Okay, so to write a complete answer, when they're asking you for a recursive formula, you have to list these 3 parts. Okay, otherwise your recursive formula is not complete. Write a recursive formula for this. So let's analyze this a little bit and just see, you know, in a recursive formula, this term depends on that term, and this term depends on this term, and this term depends on that term. So let's see what we can do. What if I were to go t2 minus t1? That is 0 minus a negative 1. That equals 1. That's interesting. Okay. So the difference between the two terms is 1. Now what if I went t3 minus t2? So that's going to be 3 minus 0 equals 3. Okay, interesting. Let's just see if we can find a pattern. T4 minus T3, so the fourth term minus the third term equals 9. So do you see a pattern here? There's a difference of 3 to the 0, 3 to the 1, 3 squared. Notice when the term is 4, they're adding 3 squared. When the term is 3, they're adding 3 to the 1. Notice that the difference between these is 2. Just setting you up, okay? So Tn equals the previous term right, plus 3 to the, well, we want, if the term is 4, the exponent is 2. So plus 3 to the n minus 2. So there's our recursive formula. T1 is equal to negative 1. That's our feeder term, right? Our starting term or feed. Because in order to calculate any term, we need the previous term. And our restriction is n is greater than or equal to 2. Okay? N is greater than or equal to 2. Good. Let's now start the general formula of a geometric sequence is Tn equals AR to the n minus 1. So using that information, we can do something similar to example 4 and find Tn. Okay, so let's take a look. Because this one is larger, the number is larger than this one, I'm going to start with this. So we know it's geometric. We know we're using this formula. So we're going to have to find the first term and a common ratio. So my first equation will be, let's take a look. 9375 equals A. I don't know A, I don't know R, but I know that N is 6, so 6 minus 1 is 5. Number 2. 75 equals AR. The term number is 3, so 3 minus 1 is 2. Now I'm going to go 1 divided by 2. So 9375 divided by 75 is 125. A divided by A is 1. R to the fifth divided by R squared is R3, because when you divide, you subtract exponents. 5 minus 2 is 3. What number times itself equals 125? Well, the number is 5, because 5 to the exponent 3 equals 125. So we can sub R equals 5 into, well, why don't we, I'm going to sub it into 2, because that looks like an easier equation. So 75 equals A times 5 squared. So 75 equals 25A, and A equals 3, because 75 divided by 25 equals 3. So now our formula becomes Tn equals 3, 5 to the n minus 1. That's our answer. Okay, let's do some it's the sum of an arithmetic sequence. There were two forms, if you recall, and you use the one of the two depending on the information you are given. So n divided by 2, 2a plus n minus 1 times d. And if you know the last term and the first term, then it's advisable to use the first term plus the last term, right? Sometimes Tn stands for the general term, but in this case it stands for the last term. See, we know the last term when we're going to find the sum of this series, but we don't know n. So again, this is about showing you know the formulas. And otherwise you're not going to get any marks for simply adding until you get to 201 and then counting. We want to know that you know the formulas. Find the sum of the series. Okay, first find n, the term number of 201. Okay, we want to find the term number of 201. We want to know how many terms there are because we need to know n. We know the first term, we know the last term, we need to find n. So we are going to use, let's see, do we use this one or this one? Well, it looks like there is a common difference, so we're going to use the arithmetic series. So our common difference is 4 and A is 5. Okay, so Tn equals A plus n minus 1 times d. So 201 equals A5 plus n minus 1 times our common difference, which is 4. So 201 equals 5 plus 4n minus 4, because that you have to distribute. And 201 equals 1 plus 4n. 200 equals 4n. N is equal to, uh-oh, I don't know why I wrote 5. See, my mind was thinking ahead to the 50. N equals 200 divided by 4 is 50. So now I can find the sum of this arithmetic series using this form. This is the simplest one to use in this case. So I'm going to use this one. You can use this one, why not? But I like simple. So Sn equals n over 2 times a plus t sub n. So S of 50 equals 50 over 2. We're summing 50 terms. A is 5. The last term is 201. And if you were to calculate that, and I'm just going to double check my work, this will actually be 50 divided by 2 is 25. That's 206. So 25 times 206 is 5150. Right? So let's keep going. We have a few more questions to do. I'm just gonna, because the black is showing through, I'm just gonna take out this sheet, and just so we don't have all that black coming through. I don't like that. It might make it hard for you to read. So let's just try to keep it as clear as we possibly can. Okay, the two forms of a geometric series are Sn equals a r to the n minus 1 all over r minus 1. Or you could use this form, and it's whichever one you prefer, all over 1 minus r. Let me just double check. Notice where r cannot equal 1, right? 1 cannot be on the bottom because you can't divide by 0. 1 minus 1 is 0, and that's no good. So okay, so again, now they want the sum of this series. So if we were to take a look at this, notice there's a common ratio of 12. Any term divided by the previous term gives you your common ratio. 36 divided by 12 is 3. Okay, so again, if we want to use this, either that sum formula or that one, what we really need is the number of terms. We don't have that information. So again, we'll do that. Tn equals AR to the n minus 1. Just checking my equipment. Okay, so 2916 equals 4. Common ratio is 3 to the n minus 1. 2916 divided by 4, 2916 divided by 4 is 729 equals 3 to the n minus 1. So to solve an exponential equation, we need to get both sides with the same base, and then we can equate those exponents. Now I believe 3 to the exponent 6 equals 729. So now we can equate our exponents. N equals 7. Okay, so we know the number of terms now. Now we can calculate our, our sum. So we can go, we know Sn equals, I think I'm going to use this formula, r to the n minus 1 all over r minus 1. So sum of 7 equals 4 times r, which is 3 to the 7 minus 1 all over 3 minus 1. And that is equal to, let me just calculate this, 4 times open bracket 3 to the exponent 7 minus 1 close bracket divided by 2. 3 minus 1 is 2, and I get 4372. Okay, good. All right, let's get down our formulas. We have A, our simple interest formulas are PRT, some future amount is equal to principal times annual interest rate times time. A equals P plus I. And the other formula we studied was this one. They all come in handy. They all come in handy. A equals P, 1 plus RT. The compound interest formula is A equals P, 1 plus R over N, 2, and that should be a capital N for number of compounding periods per year. Y is number of years times compounding periods per year. The present value formula is PV. It's just really this solve for P is A over 1 plus R over N to the YN. And what do all these things mean? This A is some future accumulated amount. P is your principal. N is number of compounding periods per year. Per year. Y is number of years. Okay, and PV is present value or present value or today's amount, right? Not a future accumulated amount, but today's amount. The formula for an ordinary annuity, and that's where we calculate some future amount. I'm just going to get all the formulas down here. 1 plus R over N to the YN minus 1 all over R over N. And make sure you memorize that for the exam. Present value is PV equals R times 1 minus 1 plus R over N in brackets to the minus YN all over R over N. Okay? Again, why don't we just, I'm going to leave more room here. A equals some future accumulated amount. R is, we have regular payments now in both these formulas, recurring regular payments. This is your recurring payments, so there's more than one principal if you want to put it that way, or there's just regular payments either coming in or going out. Y is number of years. N is number of compounding periods per year. Okay, R is your annual interest rate. I notice R wasn't defined up here, so you could say R is your annual interest rate. And let's see, PV is present value or today's value, right? Value today. Okay, let's do it. How much money should Jillian invest? How much money should Jillian invest now to have 32,000 in 5 years if the money is invested at 8.25% per annum, compounded semi-annually? So we're going to use the present. How much money should he invest now? That's your hint to use the present value formula. There's no regular payment, so it's just compounding interest. How much money should she, and she wants to have this in the future. So PV equals A over 1 plus R over N to the YN. Okay, so she wants to have $32,000 in the future. 1 plus our annual interest rate is 0. My students have come in. I'm just going to talk over the noise. 0.0825. They're being very good, so I'm just going to wrap this up and I'll be with you in about 5-10 minutes. I'll be finished soon, okay? So it's compounded semi-annually or twice a year, and this is 5 years times 2 times per year. So we have This is equal to, if you were to compute this, and I'm going to check my solution, we're going to go 32,000 divided by open bracket 1 plus 0.0825 divided by 2 close bracket to the exponent 10. Oh, I got a syntax error, so let me try this again. 32,000 divided by open bracket 1 plus 0.0825 divided by 2 close bracket to the exponent 10, and that is equal to, remember, money problems are always to two decimal places because we have dollars and cents, so that's going to be 21359.93. So it's $21,359.93. So he should invest $21,359.93 now. Okay? Okay, example 10. Marshall wants to buy a home entertainment center that is priced at $4,368.85. He plans to buy it in 18 months. He will make, oh, he's making several payments. You see, so here he's making more than one payment. So we're out of the compounding formulas. We're into the annuity formulas because of these regular payments. Now, he wants this much money in the future, right? In 18 months. He wants this amount in 18 months. That is a future accumulated amount. Therefore, we are using this formula. So this is A. This is not a present value. It's a future value. So let's just write down our formula. R 1 plus R over N to the yn minus 1 all over r over n. Okay, we want this future amount, and they want to know what should his regular payments be. He has to make 18 of these payments called R. So our future amount is 4368.85 equals R times 1 plus our annual interest rate is 9% or 0.9, and it's compounded once a year, and this is going to go on for 1.5 years times 1, then we minus 1, and this is going to be all over 0.09 divided by 1 is just 0.09. So I'm going to now, let's start solving for R. 4368.85 equals R times, 1.5, that should be 12 compounding periods per month. It's just going to be 1.5 times 12 is 18, okay? So, which is what they gave us. So we go 1.09 to the exponent 18 minus 1 is equal to 3,717 divided by 0.09 is equal to 41. Okay, I think I've done something wrong. The number of compounding periods is 12 per month. That's my mistake. I apologize. We need to put a 12 there. Okay, that will change things dramatically. So let me try that one more time. 1 plus 0.09, 1 plus 0.09 divided by 12 is that. To the exponent 18 equals that. Minus 1 equals that, and now I have to divide by this. So divided by open bracket 0.09 divided by 12 close bracket. Not sure I like the way this looks. I get 19.19471849. I'm just going to do it one more time. 1 plus 0.09 0.9 divided by 12, close bracket, the exponent 18 minus 1. Okay, now I have to divide it by this. Divide it by open bracket, 0.09 divided by 12. I guess I was right. Okay, so R is equal to 4368.85. I get 227.61. His regular payment should be, his regular payments should be 227.61, and his, oh, let's see, his, how much interest will he earn? Well, he's going to end up with 4,368.85, and he's going to make 18 payments of 227.61. So his interest will be 4,368.85 minus 18 times 227.61. I get 271.87. So I'll just check that and just make sure I'm not leaving you with the wrong answer. I don't want you to be confused. 4,368.85. He's making 18 payments of 227.61. Okay, that's what I got. So his interest is interest earned. That's okay. It's nothing to laugh at. Might get you a few meals at McDonald's. To provide an annual scholarship for 25 years, a donation of 50 grand is invested in an account where scholarship that will start a year after the investment is made. If the money is vested at 5.5% per annum, how much money is each? So they're going to put in 50 grand today, and then they're going to pull money out of that investment. So this is a present value question. PV equals R. Okay. 1 minus 1 plus r over n to the negative yn all over r over n. It's compounded once per year, so n is 1. That's an n. So our present value is 50,123 equals r. 1 minus 0.055 over 1, which that stays the same. No, my mistake. Better fix this up. 1 minus open bracket 1 plus 0.055 to the, it's 25 years minus 25 times 1. It's one time a year, right? It's compounded annually all over 0.055 divided by 1 is just 0.055. 0.055, that's a times 1, okay? So let's work that out. I'm going to get 50,123 equals R times, what does that work out to be? Okay, let's plug it in our calculator. 1 minus open bracket 1 plus 0.055 close bracket to the exponent open bracket negative 25 close bracket equals that, divided by 0.055, and I get 13.41393,266. Just let me just double check my work, because this is, it's easy to make a mistake. So it's 1 minus open bracket 1 plus 0.055 close bracket to the exponent open bracket minus 25 close bracket equals that, divided by if you want to see, divided by 0.055, get there, and that's what I got. Okay, so R is equal to times 50, 1, 2, 3, $3,727.47. And I'm just going to check that. 1, 2, 3, 50,000 divided by 13.413932266. 3,000. Okay, so each scholarship is $3,727.47. So I'm just going to remind you that watching these YouTube videos is not enough. Again, I'm going to keep reminding you, practice your review sheets, redo your test, do your practice test, and good luck studying.